Hello everyone, today we have another white box technique, and that is path coverage. In path coverage, our goal is to test all possible paths in our code. So what are the possible paths in our code? Let's have an example and understand our technique through this example. If he says if x is greater than 3, print hi, else print boy, okay? If y is equal to 5, print good, else print bad. If we use decision coverage on this code, we begin to draw our flowchart. Here x is greater than y, hi or bye, y equals 5, good or bye. Or good or bad, not bye, okay? Bad. Okay. Like we always say, in decision coverage, we have two decisions with 4 outcomes. We will need 2 test cases. The first test case will pass through, for example, yes and yes. The second test case will pass through no and no. Or we have another solution, yes, no, and no, yes. So this is decision coverage. Path coverage, on the other hand, must test all the possible paths in our code. So what are the possible paths in our code? Here we have, for example, this is 1, 2, 3, and 4. These are the decision outcomes in our code. Path coverage, like we said, tests all possible paths. So he will go through 1, 3. This is path number 1. And also 1, 4. So this is path number 2. He will also go through 2, 3. And this is path number 3, and 2, 4, and this is path number 4. So here in this code we have 4 paths. We will need 4 test cases to test this code. Okay, is path coverage better or worse than decision coverage? Okay, it is better because it covers more paths. Okay, decision coverage will need only test cases, and it will pass, like we said, through, for example, this and this only. But path coverage will pass through more paths. But what is the problem with path coverage? We always say that we can achieve 100% decision coverage. Depending on the problem, we begin to draw our flowchart, we begin to think how will we achieve 100% decision coverage with 3 test cases, 4, 5, or any number of test cases, but it is achievable. The problem with path coverage is that sometimes we have a lot of paths. We have infinite number of paths. Let's have an example to understand this. If this code, here our code has 2 if statements. If this code has 10 if statements, and each one of them with yes and no decision outcome. So here we will have 10 ifs, 1, 2, 3 until number 10. And in this case, like decision table, if you remember decision table in black box techniques, we said that number of test cases is 2 to the power of the number of questions. Here it is the same, 2 to the number of, or to the power of number of if statements, which is to the power of 10, and this gives us 1024 test cases, and this is a huge number. What if these were 2 to the power 10, 20? This will be a very big number that is not achievable. So that's the problem, is that sometimes we cannot achieve 100% path coverage. If we have, for example, a for loop, okay, and this for loop has a number that is counted, okay, and it ranges from 1 to x. This number x will have any number. It might be 10, it might be 1 million, okay, and in this case also we cannot achieve 100% path coverage. So we should use path coverage in some situations, but our goal should not be to achieve 100% of it, okay. We should cover some of the paths in our code if we need, or in a simpler way we can use decision coverage if our code is not complex. Thank you, and see you in the next video.